Okay, friends, we have our third video in the 4.3 series, and we're talking about a Norman window, which consists of a half circle atop a rectangle as shown. Now, we should say that the outside of the window is here. I just dashed this to say that, look, it is a half circle on top of a rectangle. If a builder needs an area of 6 square feet, so that's the area of the window, what is the least amount of aluminum for the exterior of the window? And this is an optimization problem. So let's begin. Now, we do have a picture here, but I don't like the fact that I don't have any information on my picture. And so I think that we should include some variables. Some of you would want to put X here, but I'm going to do something different. I'm going to put R. And R here as well. And the reason that I wanted R is because R relates to my circle, which has a radius of R. I'm also going to use Y for the height of my rectangle. So now that I have a good picture made, let's go to step 2 and let's figure out what are we trying to optimize here. And we're trying to optimize the least amount of aluminum on the outside. And so I think that's a perimeter idea. And we're looking for some number of feet. And so now we're going to make the formula here. And if I just start on the rectangle, we see that we can go Y, 2R, and then Y. So 2Y plus 2R, and then I'm going to need that half circle. So 1/2, and the area of a circle is 2 pi R, and murder will occur, and this is our perimeter. I'm going to simplify. 2y plus 2r plus pi r equals p. Now, what situation are we in? I certainly don't think we're in that one variable situation because I have a y and an r right here. I can't take the derivative, and so I'm going to need to make a constraint. And that constraint is based upon what? Oh, it needs to have an area of 6 feet. Now, 6 is an area idea, and so certainly I can talk about the area of a rectangle, y times 2r, that's just our area formula. But then I'm going to need the area of that half circle, so 1/2 pi r squared. Sensible? I hope so. Now, step 5 involves us using our constraint and our equation from step 3 to make one equation. And so it's pretty clear that I'm going to use a substitution here. And do you want to substitute for r, which is located in 2 spots, or for y, which is located in 1? And it's a no-brainer. We have to go for y. So y will equal certainly 6 minus 1/2 pi r squared. And then we're going to divide all of that mess by 2r. Okay? So now that we have the rock, we can put it right there. We can say that P of R is equal to, I'm going to put that 2r. I'm going to have pi r. And now I'm going to have 2 times that ghastly expression right here, 6 minus 1/2 pi r squared over 2r. Awesome. I want to do just a little bit of housework, minimal housework before we go, and certainly those 2's can do the dance. And then I'm actually going to bring that r to each part of the fraction as well. So I'm going to say P of r is equal to 2r plus pi r plus 6r to the negative first minus 1/2 pi r. We saw the r squared and the r. We subtract exponents and we're left right there. I'm going to do one last piece of work here. Pi r minus 1/2 pi r. We'll have 2r plus 1/2 pi r plus 6r to the negative first is equal to my perimeter. Now, we've done it. let's take our derivative yet. And the derivative is going to be 2 plus pi over 2 minus 6r to the negative second. We'll set it equal to 0. 2 plus pi over 2 minus 6r to the negative second. And I'm going to bring this term over. And so we'll have 6 equals 2 plus pi over 2. I guess I should include the over r to the second, yes? And the reason I'm doing that is because I'm going to bring this term over there. I'm going to bring all that trash underneath. And now r squared is equal to 6 divided by all that garbage, pi over 2. Now, how do I solve for r? We're going to take the square root. And when we take the square root, you can't lie to me. And that means that we should probably include plus or minus. We'll do that up here. So r is equal to plus or minus the square root of 6 over 2 plus pi over 2. But really, that minus we can't use it because the radius has to be some positive value. Now, we need to begin to test these things. And so we should think about the domain for our original problem. Now, we certainly see that the radius here has to be some non-zero value. And the reason for that is that we have to have area. They told us that the area was 6 feet. And similarly, if you look right here, if r is 0, the whole thing will wipe out, and I can't have 0 equal to 6. And so 0 has to be strictly less than r. Now, could y technically be 0? If it could, that's going to be where our maximal value is. And I think it could be because I could just have the top of that circle equal to it. And you could see similarly, if y is 0 on the constraint equation, we would just be left with this. So 6 is equal to 1/2 pi r squared. We would multiply by 2, we would divide by pi, and then we would take the square root. So it looks like we're going to have 12 over pi equals r feet. Technically, there should be a plus or minus, but once again, I'm only concerned with the plus. So, what's the prize now? I'm going to be putting 3 things into my original equation, which was right over here. That's my simplified version, yes, before I took my derivative. And so let's begin testing these things. I need p of 0, but I really can't do that. I can take the limit as r goes to 0 of p of r. What's going to happen? That piece is going to be 0. This piece is going to be 0. But this piece, that's 1 over r. And so that's going to go to infinity. That's certainly not going to give us the smallest value. Let's go again. Let's go for the value that we found here. P of square root 6 over 2 plus pi over 2. I should say that it probably looks more like that. And I think what I'm going to do with my calculator is I'm going to say 6 divided by 2 plus pi over 2. And I'm going to store that as 1.68. I'll store it as a. And then I'll just go here and I'll say 2 times a plus 0.5 times pi times my stored value plus 6 times a to the negative first. And I get 9.57, and that's square feet. Or I'm sorry, just feet. Let's go for our last value, please. And now I'm going to be putting this root pi over 12 over pi. And I'm sorry, this should be included because certainly I can have y equals 0, and so r can equal that value. I'm going to do the exact same technique. I'm going to take the square root of 12 divided by pi. I'm going to store that as b this time, and I'll put it right into my equation. 2 times b plus pi over 2 times b plus 6 times b to the negative first. And I get 10.0489. What does that tell me? That we have our minimum perimeter with the value that we wanted. And the final thing that we need to do is we needed the least amount of aluminum for the exterior of the window. And that's right there, 9.57 square feet. And that's not the exact value. If I go back in time, I can see that we could put this whole thing in. But I think that a decimal approximation here would probably be just fine. And that's the optimal amount of aluminum to have an area of 6 square feet.